Good morning and welcome to our session about software dependency analysis with graph databases. My name is Oliver, this is Philip. We both are software developers and work for InnoQ, a software consultancy based in Germany and Switzerland. And most of our working time we spend in big and enterprisey projects with very complex and huge software systems and a lot of applications and modules and interdependencies, and it's always very hard there to track all the dependencies, to keep an overview and so on. And so end of last year we started a project. Philip was the initiator, and it's called Repo Census. It's a web app using Maven in the background, and the goal is to utilize graph database technology, Neo4j and Cypher, to explore and analyze dependencies in big software systems. Yeah. And today we want to show some of the ideas and concepts and hope that they are helpful or might be some good insights for you. We'll start just with a very brief introduction or recapitulation of software dependency management, just to ensure that everyone can follow the upcoming topics. Then Philip will give an introduction of the web application of the Repo Census and show the main use cases. Then we will look on the underlying data model, of course a graph model, and how we represented the software dependencies in this model. And then we will show you some hopefully interesting queries and some Cypher stuff. Okay, Philip will start.
First question, who is using Maven or is familiar with the way Maven works, basically? Oh, that's great, because then I can speed up a little bit the introduction. So for the Maven is basically a build tool that is used for creating software applications that use different dependencies, since that was our first idea to use Maven as a first so-called use case for this application. As you can see, so this is a draft build file of a Maven project. Could be any Maven project, but normally you have this identifier that identifies this specific build. So let's say the group ID, artifact ID, and the version as a specific artifact. So it's unique, identifiable within the whole Maven ecosphere. And also you can use specific dependencies that are also identified via group ID, artifact ID, and version ID. And these dependencies are then integrated while during build time, and then can be used within your application context. And you will, of course, end up as a graph. So the simplest way is just one node with no dependencies, but normally you will end up with a lot of dependencies. And that is just the first hop. So this is the direct dependencies, and if you go a little bit further, you will end up what it's globally called as transitive dependencies. So these are the dependencies of the first level of dependencies. And of course, if you follow the path again, you will end up in a lot of dependencies. So we have examples where you have only, I think, 3 or 4 dependencies on the first level. And if you map the whole route through all the dependencies, you will end up in 3,000, 4,000, so a lot of complexity. And the thing is, you normally use, let's say, common test frameworks or log frameworks, and they all have different dependencies, and you often will end up with so the same artifact but in different versions, and then you will end up in different licenses, and you will surely will end up in issues. And that was, for me, since I started working in the consulting business and also in software development, I always had this problem. So that's a software, it's developed for, I don't know, 10 or 20 years. And these are our main dependencies, and now we will like to update the Java version, or we would like to maybe change the whole license model of the software. And yet then in the past you need to check every path manually and control if that's compatible, or if there are any problems if I update a dependency version, for example. So these are some use cases we implemented at the very beginning. At the moment, we are just starting with the project, so it's like a little bit side project. And the first thing we had as a goal was to get a better overview, because having a lot of XML files isn't really a useful observation instrument. And also the thing what changed between two versions. As we will see later on, you can easily track what happens between version 1 and maybe version 3. And also you can estimate the impacts if you do an update of a dependency. The next thing is then license issues, of course. If you're using dependencies that are GPL, for example, and you plan to publish your software as a distribution, for example, as an Eclipse license or Apache license, you will have some law issues, basically. And the next thing is security issues. If you know that the dependency solves some security issues in a specific version, you need to check your whole project if you have an older version as a dependency. We already built a simple software about this, and we, from the beginning, we started with a queue to be more scalable. So the end result, or one of the end results we plan to do, and we hope to achieve during this year, is to get an index of the whole global Maven repository. So if you are an open source developer, or you're developing tools that need to be accessible to the public, then you use this global Maven repository that is publicly accessible. And basically the default dependency, or the standard default dependencies, can be then received from this repository. So again, that's just for the short overview of the system. You see Neo4j has a big place in there. We have some workers that are doing basically the indexing of the artifacts and store everything in a Neo4j graph. And also we have a small web UI. So what we basically would like to achieve is having a basic search field, so keep it quite simple, and then you have basically a short overview about the content of your Neo4j graph, and then we have one of the examples what a dependency graph might look. So in the center you have this basic dependency. There should be a tooltip. Yeah. That does not work. So normally this is then your whole infrastructure. You see this is the central artifact, and then if you go further outside you will have the different layers. And of course if you would like to have a look in a specific artifact, you can simply click on it. You see the search query was pre-filled. We can use also this query for, let's say I would like to have an all the artifacts that are in the group of Neo4j, for example. You basically have the POM of the artifact, so that's basically the model that is based, the artifact is based on. You can see what elements are using this kind of artifact. You can see what elements are used by this artifact. You can drill down on a specific level. And you can even have, so we have several versions here. And one thing is, so I'm now at version 7.6.8, and I would like to have a comparison between version 7 and 8. And you can see some changed versions. These artifacts are gone in this version, and these artifacts are basically added during this version. If you would like to have a better overview, you can also follow up a timeline, and you can see, so this is the version 7, and you can see these artifacts are added basically, and if you would like to go into future, you can see here is a version update. Maybe let's see if something, okay, so basically there are just updates in versions. And again, so we really try to use links as a basic navigation method. So if you have an artifact that seems to be interesting, you just click on the artifact and you're then in the new context. So last thing I would like to show is if you let's say Neo4j, you can just go there, search. And then you have basically all the artifacts that are within this group. So a group is like a folder from the context. And you can see all the artifacts and the versions. So to introduce the basic graph model that we are used to map basically the static XML tree structure and all the relations in between, Oliver will now say some words.
Yeah, thanks, Philip. We hope you have a good understanding or first impression of the use cases we have and of the problems we might have. And now, of course, this is the Graph Connect. We will look on the graph model and we'll show with how you can perform these searches with Neo4j and how the queries and the graph model look like. We start with the graph model. First, of course, we have to identify the elements we need to transform from the Maven dependency model from the POM into our graph model. So these are dependencies, version groups, and licenses for our use cases. So what we did to form our conceptual model, we did a little bit like whiteboard modeling. So we just drew some circles and lines and transferred the elements from the Maven model into a conceptual model. What we have here are the group, two group artifacts from one company, for example, or from an organization or from a project. For this group, in this group are a lot of artifacts, and these artifacts, of course, have a lot of versions. And the version is the most central element because there we have all the dependencies. The dependency tree is on the versions. They depend on one another. And also the licenses are tracked by the versions. Yes, and one great thing with graph databases is that if we transform this conceptual model into a physical model, this is very easy. It's nearly exactly the same. So this is our physical database model as it looks like in Neo4j. So here you see the labels for the nodes. We have group, artifact, version, and license info, and the labels of the relations we need to represent between these nodes. It's a little bit simplified, but it's the core of the real model. Okay, we can now look into the console just to see some data in this model. We start with a simple Cypher query or with a Cypher query and just fetch one artifact version by example. We just fetch JUnit and look at the elements we see here. So we see the JUnit version, we see the license info, we see that this is a version of the JUnit artifact, and this is an artifact of the JUnit group. So here we can just see the versions, and for example, by double-clicking here, we could see all the other versions, and sometimes too many neighbors, the console will not show it to us. So we take another Cypher query. This is now a sample project, and here we can see the dependency tree, or some dependencies of an artifact. And in the same way, if we want to look also not on the direct dependencies, but on the transitive dependencies in this model, we can just use the star notation and give say, okay, we want first and second level dependencies, and we would get the next level, and of course could even dig deeper, but we will see very quickly the graph becomes very complicated, and it's not really helpful for us to see this in this way. Okay. No, console hangs a little bit. Okay, and I take the next query. Yes, so this is why we mostly said, okay, the graph is a very good model to represent the data, but it's not always the best solution to represent or to visualize it. It looks might look impressive, but it will not help us so much. So that's why we very often transform the graph model into lists or tables. Yeah, and here's the same. We can now we have the Neo4j, a Neo4j model, and can have a look here into the transitive dependencies just by using some Cypher queries, and yeah, see all the dependencies. So this was just to have a look into the database, and okay, now we show some more sophisticated Cypher queries, but start with a very simple one. How we find a version. If you just click on one thing, Maven has a very good model, namespace model, to identify artifacts in a globally unique way. And so we use this model usually to find the initial node, and then can get some more data. For example, we can match a version node with here we use the label as a version label, find it by the unique identifier, and then we map some labels from the version to see if it's marked as a to-do or as processing, so if it's already processed or as in the background the processes are still running. And of course, for the search, we just use the built-in regular expression features from Cypher, and can search a version. Here, for example, can search all versions beginning with InnoQ to find something. If we want to explore something about the licenses of an artifact, we can first match this version, or the version we want to analyze, by its unique identifier, and then navigate over the license infos and pick us the license name and the URLs, as you see in the picture below. Then you saw when we have the view of one artifact and we want to have a list of all other versions of this artifact, we again can express this in a very simple Cypher query. We just start with one version that's currently presented, and then navigate over the version of relationships to the artifact, and go to all other relations and can then return them. Here I think we had this in the console before. This is a Cypher query to get the direct relations of an artifact, and this would be the Cypher query to get also the transitive dependencies. It's very important in most cases that we also give a limit here, because very often the transitive dependencies can explode in complexity, and then the queries will become very slow. And if you set a limit, for example, for 10, and if there's really one realistic artifact which has a greater or bigger dependency tree, there might be something wrong anyway. So maybe I don't know if I should explain the Cypher queries more. If you all know the Cypher queries, maybe we can say here just to explain this query, what we are doing here. First, in the match clause, we say we want to have a node which is a version, and in the where clause we say we give a regular expression to filter it by its unique ID, and we bind all this nodes we found to the variable v, named v. Then we perform an optional match and go down the relations that are labels depends on compile or depends on runtime. These are the scopes of the Maven build model, and bind all these dependencies we find here to the variable other, named other. And then we make the distinct on it, because a lot of dependencies there will occur on a lot of passes we have here, and then we return the dependency IDs. Okay. Then if we want to have not only the results of all dependencies we have in the transitive way, but we also want to know the path. So why is this a transitive dependency here? Then one way doing this is that we use some more Cypher features. First we get all these dependencies and bind them to the variable other, but what we also do is we fetch or store the complete path we have here from the version we are starting with and all the dependencies, and bind these passes to the variable p. And then we do a little bit functional expressions on it. We take all these nodes in all passes, extract, or it's a kind of mapping the nodes to the unique identifiers. We say just the tail, so we skip the first element because this is the version we started with, and then we can get a comma-separated list from the complete dependency or complete dependency tree, and this can be transformed, for example, into a JSON model to make it available for external applications. Okay, one more query. If we want to see not only the license of the current artifact or of the current version, but of all versions that we get by the dependency management into our WAR file, for example, of course we have again to go down the dependency tree. There's a lot of depends on to follow all the relationships which depends on compile and depends on runtime, and fetch all the license info nodes we have here about the has license relationship and bind them to the variable L. And then we can put them into a list. And what we see is, and this is now a real example here not very much artifacts or dependencies. I think it's just Spring. And also, if you just use Spring, and you could guess, okay, Spring is Apache license, I think, Apache APL2. We get a complete plethora of all available open source licenses by just adding Spring, because Spring brings a lot of dependencies with any kind of open source license. And here are also, for example, some GPL licenses which might be a problem for some of our customers. Okay, I think then the last Cypher query, this is one query written by our colleague Sylvia. I would have needed, I think, 4 distinct Cypher queries to build this view. This is now what we want to see here is the change screen you saw, where we see what are the common artifact versions two artifact versions use, what are the changes in the versions, and what are artifacts only the one version needs, and what are the artifacts only the other version needs. And so what we are doing here is there are four blocks, and in each block we walk down the depends on relations of the original version and of the other version. And then in the first match block, we find all the versions where they depend on the same version and put them to the variable common. And then in the other track, but I think I have to speed up now, yes, we take only the common artifacts where the version might differ, and here those artifacts which are only in one tree and not in the other. So this is the graph, the complete graph, this Cypher query walks along. So we can really, for this complete page expression we see here, we can put this into one Cypher query, and this is the resulting graph we get. And the box nodes here, these are our result sets. Okay, now to finish, Philip will just give a brief overview about the current project status and next steps.
So again, this project is a quite early stage. Our main goal is to have at least a working web application with one of the goals we try to achieve this year. We still have some limits on the system, so as Oliver mentioned, we have some gaps to figure out what is optimal depth of the query. So as you can see, we have this drill down function, and this function was necessary because if we would like to display the whole tree of one of the artifacts, sometimes the system just crashes. The outlook is so we have some features we plan to achieve this year. The first one would be the support for multiple repositories. So at the moment we are just using the global Maven repository, just because most of the stuff you're using in your daily work is in there. We also would like to track additional attributes. So at the moment we only have this basic Maven model attributes and the license. But we would also like to, let's say, have an overview of the artifacts of one organization or of one developer, and maybe also repositories. So let's say we have a specific artifact, and I would like to know in which repository it is available. Support for multi-user and the support for project uploads is some kind of software as a service approach. So one of our goals is to put the thing on a web page somewhere, and you can then basically upload a Maven POM, and the system will give you some feedback or some suggestions or some warnings maybe. And also support for social login to keep the entry point quite low. So if you have a GitHub account or a Twitter account, you could basically use the system in your user scope. So maybe create your own projects page and get your own reports for some specific POMs. Also, one of the goals was to widen the support for repositories. So in our work, we often have projects that tends to not only using Maven as a repository, but also a Node or even Rails, or if you're deploying things, it's our RPMs. And then we have this bunch of different applications in different languages, and I think it would be really useful to have one tool that gives you this global overview. And for example, if you need to decide how long it would take to update one little piece of your whole software system, to estimate how much effort it would be. Also, another thing is to integrate it in a build process. So let's say if you have a continuous integration system running and you need to update the feedback from the system every time, then we will create some public API, and then let's say a Maven plugin can use it and can also be used to fill up or to update the data in the Neo4j system. Another approach is to go deeper into the artifact itself. There's this nice project called QA Assistant that may enables you to get an insight into your artifact itself. So it's a jar or a war, and you can see which kind of, so for example, which GDK was used to build the system, or which, if you're using dependency injection, what is your package level, this kind of stuff. And I mean, to rebuild this by our own does not make sense, and so we try to find the tools that support this kind of insight and try to then integrate it, maybe as a kind of plug-in system or something like this. Yeah. So these are I think almost the last slides. So at the moment we are trying to create a project page. Then software as a service I already mentioned, and the last thing is to create some kind of virtual machine that you can download and then have your system in a web browser and play around with it. That's all. Yeah, thank you.